Okay, question 25. A formula connecting speed, distance and time is s equals d divided by t. We're told that the distance is 160, so two significant figures. Time is 7.2, and we're asked to work out the upper and lower bounds for s. So, firstly, because we're talking about upper and lower bounds, we need to work out the upper and lower bounds of the two variables that we've got. So if the distance was 160, meters or whatever it is, and to two significant figures, what would be the maximum and minimum value that this could take? So to do this, we could consider, what two significant figures mean. So two significant figures mean the first two non-zero numbers, the 1 and the 6. And what I like to do is think about what would be the next possible number up from, from 1 and 6. So the next one would be, 170. So if we consider we've gone from 160 to 170, that tells me, what this is increasing by. So the next, so we can see it's increased by 10. Now, what it's increased by, if we now divide that by 2, so we take the 10, divide it by 2, that gives you 5. And that tells me that this will split into 165 because it's 160 plus 5, and 155 because it's 160 minus 5. So all I'm doing is considering what would be the next number up to two significant figures from 160. So I've said that's 170. Worked out what the actual distance is between those numbers, which is 10. Halved that actual distance, and then used this number to help me work out the upper and lower bounds. So the upper bound would be 165. The lower bound would be 155. Now, in actual fact, we know that 165 itself can't round to 160 because that would round to 170. Okay, so generally what we say is that, for distance, we can say that the exact value, so I'm going to call this x, is between 155 to 165, where 155 is included. So I've said that x is greater than or equal to 155, because if it was 155, that would round off to 160 to two significant figures, but it can't actually equal 165 itself. So I could write my bounds like this. If the question asks for error intervals as well, this is the way that you should give your answer anyway. So it's a good idea to get you into the habit of writing your answer like this. So for the second bit, t equals 7.2 to two significant figures. So again, my two significant figures are the 7 and the 2. So the next digit up from 7.2 is 7.3. So 7.2 to 7.3 is an increase of 0.1. So just like we did before when we worked out what the increase was, we then need to half it, because that splits the bound, or splits it so we can work out the two bounds. So half of 0.1 is 0.05. And then we can just add and subtract this from that to then tell us what the upper bound is. So the upper bound, if we just add it on, 7.25. The lower bound would be 7.15. And again, we can write this down, so as a boundary. So t is between 7.15. I suppose I really should use the letters t and d for these, and 7.25. Where 7.15 is included, because if I had 7.15, that would round to 7.2 to two significant figures. But 7.25 itself cannot be included. Anything up to that can be, but 7.25 itself would round to 7.3. Now it says work out the upper and lower bounds for s. Okay, so what that means is what is the greatest possible value for s, and what is the smallest possible value for s. And I can use my bounds here. So if we think about it, how do we make the biggest possible number by dividing? So I would need to make the top the very biggest possible number I could think of, and make the bottom the very smallest. Okay, so if I had a really big number at the top and I divided it by a really small number, that's going to give me a really big number. Okay, so to find the upper bound for S, I need to do a big number divided by a small number. So that's going to be the upper bound divided by the lower bound. So in this example, my upper bound for D, remember it's D over T. So the upper bound for D was 165, and that's over the lower bound, which is 7.15. So I can work that out in a second. And the lower bound for S, how do I make the smallest possible answer for this? Well, it's going to be the opposite way round. So I need to have the smallest possible number at the top and divide that by the biggest number possible on the bottom, because that will make the smallest possible value for S. So I need to have the small value at the top, so that's the lower bound, divided by the upper bound. And looking at my values for T, because remember the second value is T, the lower bound is 7.15, and I'm dividing it by the biggest value of T, which was 155, so divided by the lower bound. So let's work this out. Starting with the upper bounds, 165 divided by 7.15 gives me 23.0769 ... And my lower bound, 7.15 divided by 155. I've done this the wrong way around, just noticed. So I should have done D divided by T. So I noticed that I've made a mistake because my values are completely different. So I've gone wrong. So it's D divided by T. So distance was the numbers in the hundreds. The T was the numbers in the units. So I should have actually done that. So it was my lower bound divided by my upper bound. Let's try that again. 21.3793. Okay, so work out the upper and lower bound, give your answer to 3 significant figures. So 3 significant figures, 3 numbers, not including 0. You do include this 0 because you've already started counting significant figures, so any zeros afterwards are counted as significant. So that's going to be 23.1, that's my upper bound. And my lower bound is 21.4.